Hello everyone, welcome to my first episode of Recreational Programming with me, Mr. Herb Coding. Definitely didn't steal that intro. For this first episode that I'm making for YouTube, I'm going to make a 3D renderer in JavaScript with no knowledge of 3D renderers. A few months back I made this website for me and my friends, nice boys nice, in JavaScript. Not knowing anything about JavaScript, and I still don't know anything about JavaScript 10,000 lines later. It's like a little house, you go through the door. Inside, we've got a TV playing skate videos. We make a bunch of different skate videos. We've got the cat. We've got the cat mini game, which is based off New Super Mario Bros. Bob-omb game, if anyone remembers that. We've got the shop, selling t-shirts. Made a Club Penguin copy. There I am. Yep, that's me. Also made Ripped Off Friday Night Funkin'.
早上好，中国！现在我有冰淇淋，我很喜欢冰淇淋。2个礼拜以后，所有激情就。
Yeah, John Cena fish.
You still make me cry.
Nice. Let's go through what my idea is. We have x, y, and a z value for everything. And that's going to have a fixed x, y, and z value for the world. And then we're going to have a camera x, y, and z value. So why do we need a camera x, y, and z value? If the player is looking this way, and then they turn around and start looking this way, the object that was here is now going to be on their right. So we're going to fix the player's position looking forward, and as you move the mouse, it's going to change this rotation value, and then this object is going to have to rotate around the player by a certain amount of degrees. So whilst this object has a fixed x, y, and z value in the space, the camera x, y, and z value is going to change based on where the player is looking. How is it going to change? This is our radius. This is the player right here. This distance is the distance away from the player. We're looking top down onto the player, so this is our z value. And then this is our distance along, which is our x value. We're just going to focus on z and x for now. Let's say the player starts off looking at this angle here, and then they turn around to theta 2. And what we have is the original point they were looking at is xz. Now they're looking at x2, z2 over here. If we draw triangles like this, and use a bit of geometry first of all, is this Z shape here, chook, 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 means that this angle is also the same as this angle here. So let's draw that in. Theta 1 here, and we also have theta 2 over here, because we have that same Z shape here. So we know the radius, which is the hypotenuse of the triangle, that's the longest side, and we know this angle, and therefore we can calculate this distance here, which is Z2, and we can calculate this distance here, which is x2. x2 equals r, and we've got the opposite, so we use the sign, theta 2, and we got z2 equals r cos theta 2. And that's just me using this is how I always remember it, so if we want the opposite, we cross it out, and then we have the sine of the angle times the hypotenuse of the triangle, or ka. That's how I learnt it. This took me quite a while to figure out, I'm not going to lie. I did some crazy things before. Yeah, here's a look at some of the crazy stuff I was trying to do. I wasted a lot of time. Okay, we have a square, x, y, and z, that's the corner 1, corner 2, corner 3, corner 4. And then we're just drawing the corners for the x and y values. So let's have a look at what that does. Okay, there we go. We have our square.
Perfect.
Yeah, we're making the back rooms, so I missed that out. But yeah. When the mouse moves, we're storing the mouse x. Rotation is going to be equal to mouse x over the canvas width, and then we're going to divide that by 360. Oh no, we're going to times it by 360. Maths. So we're getting how far are we along the width, and then we're going to map it between 0 and 360. And then let's just log what that looks like. So 0, 360, perfect.
Hooray!
Next up, we want to change the x and z values based on these functions here. So let's write that. And then we're going to say x equals fixed z times math dot sine, rotation. So actually, we have a problem to solve. We've got the camera x, y, and z values. And to display them on the screen, we need to convert those to just an x and a y value. We need to think about perspective. As things get closer, they get bigger, right? And as they get further away, they get smaller. So the other night, I set up one of my slippers a certain distance away from me and the other slipper twice that distance away. And I closed one eye and I tried to see, is the slipper that's twice as far away half the size, right? And it kind of looked like it was. So I'm going to say that if an object is twice as close, it's twice as big. So we've got our screen, and then we've got a square on the screen. If this object moves twice as far away, it needs to be half the size, which would look like this. We need to go from this coordinate being 1, 1, to it being 1.5, 1.5. The new x coordinate is the original x coordinate plus the width of the screen all over the z value. Okay, so let's put that in our code and see what happens. Alright, the moment of truth. And nothing works. Okay, now, let's see what that is. Wow, it is certainly doing things and is certainly not drawing anything at all. I'm confused. Okay, so basically it just looks like our z value is really wrong. Okay, so it's just not working at all. Oh god, I love coding.
Bruh.
Oh, look at that. That's a bit better. So as we move our mouse, that green square is moving, and it is moving how we want it to. It's moving a lot times math.sine of rotation. Oh, contains an expression that contains an angle measured in radians. That would make total sense why it's jumping around like that. 6 hours of debugging can actually save you 5 minutes of reading the documentation, guys. So what is going on? Alright, so that's going to draw the other 4 corners of the square. Let's see what's going on. It kind of is working somewhat. Where the hell? Why are we losing 2 corners of the square? We need to add fix X. Oh. Then it's going to be way over the ways. Oh, we did it. There we go. For some reason, my Z is not working. So let's rethink our work. Okay, let's try that. Whoa. So confused. I'm so confused. Why has that not changed anything? Why are they not different values? Because I didn't do a plus. Whoa, did you see that? Do you see that? Do you see that square? It's going round.
What is he doing?
He's beginning to believe.
It gets too wide here. It's because we don't know the function of z. Even that's weird. I haven't changed that. Did I change it? What is the problem now? So the problem now is that we don't know what we're doing. What the hell? Dude, what the hell? Alright. It does kinda look 3D.
Ah, shit. Here we go again.
So I think I got it. We've got this diagram again, where we've got, this is our z value, this is our x value, and then we've got this line right here. That's our square, and this is a player. We're looking top down. Obviously the square has an x value 1 and an x value 2, and as the player turns around like this, these x's need to move around the player in a circle. And the thing our code didn't account for is that this object, it has an initial angle away from the player that it already is if the player is looking forward, but we were just setting that angle to be 0, which would basically mean that this x was here and this x was over here. So what we need to do is we need to find this initial angle theta here by taking the y and the distance from the middle of the screen, the canvas width over 2 minus x, that's the absolute value of that. And then we need to divide that by y, because if we want the angle, it's the opposite over the hypotenuse, and then it's the inverse sine of that. And then we need to take away this angle from the rotation, or something like that. So let's just try that, and maybe that's going to work.
You serious?
Back to the drawing board. It's 2:30 AM. I think we did it. Okay, so I did a lot of thinking of how to go from XYZ to X and Y. So our fixed grid XYZ of the 3D game world.
Ah, shit! Here you go again.
Okay, let's see what that does. Shouldn't change anything. And it's completely broken. What is going on right now? Actually, what is actually going on? It's 2 PM. I need to eat lunch. So 130 divided by 2 is like 515. Yeah, and that is indeed a square. This is why I don't like JavaScript. Look at this bug. We're going through all the shapes in this shape positions array. We get this new shape, and then we log the new shape. So let's run the code, and let's look at the output. Notice that x is 56, x is 56, and x is 93, then x is 93. Right, I want to take that new shape. I just want to put it in an array. Just by adding this line of code here, we're somehow going to edit the line of code behind it. X is now 89 for all of them. I've created this new shape, and I want to put it in an array. But by putting it in an array, I change the shape in the past.
5 hours later.
The JavaScript logging doesn't store a snapshot of the thing as it is right now. So
that was a f***ing lie.
So if you actually want a snapshot of the thing as it is right now, you have to do this. I hate JavaScript.
Okay.
So I started from scratch again, following kind of what I'd learnt from previous attempts. Basically, I went back and looked at my kind of maths and realized that my calculation for the start angle was slightly wrong. When we're looking forwards and there's an object in space here, there's going to be an initial angle that object resides at from the player's point of view. And to calculate that initial angle, we have z and x. I realized that that's going to be different in each 4 quarters of the circle. I was trying to work that out here. It's going to be different tan, just because, for example, in this section of the circle, z is the adjacent to the angle, but in this section of the circle, you can see z is the opposite to this angle here. So it changes around. I got that figured out, and we've got that all in here. I also realized we can calculate r using the x and z values based on which segment of the circle we're in. So r is going to be x or z times the sine of the initial angle. So we've got this initial angle here, we've got x and z, and then the sine of this initial angle with one of those things is going to give us the hypotenuse of the triangle, which will be the radius. So then I was like, whatever we were doing for calculating z before was really ridiculous. I was speaking to my partner about it. She mentioned a physics lesson in GCSE which talked about finding the position in the sky of a star and then using that to find how far away the star is, and she drew a diagram kind of like this. But it made me realize that I was thinking about it all wrong, right? Because we need to think of the FOV, which is this theta here. I only named it FOV because I saw that in Minecraft settings, and now I know how it works because using that we can calculate how the screen needs to get bigger over as Z increases, right? Because this A here is tan of FOV, that's A. If we times that by 2, we get these distances here and here. Then if we add the size of our screen, we get the total of what we can see. I've called it total C. And then if we take the size of the screen and we divide it by total C, so for example, say that this total C is a value of 2 and our screen has a value of 1. That means everything, as we put it onto our screen, needs to be half as big. If the total C became 4, our screen size is still going to be 1. Then everything's going to be a quarter of the size. And this value here depends on Z with the FOV. And to test that, instead of just drawing a square, we're drawing a rectangle that is 1.8 meters high and 0.5 meters wide. So we've got a rectangle that's the size of the person. So let's put this person 5 meters away from us, right? That's a person 5 meters away. Kind of looks right, you know? If we put the person at 10 meters away, you know, it does kind of look right. If we put them at 100 meters away, if you think of a sprint of a 100-meter pitch, you know, yeah, it's looking right. So yeah, the next challenge that I want to do, I want to draw a corridor. Okay, that's rectangle 1. Okay, that's rectangle 2, and make rectangle 3.
Oh my God, my Shayla.
There's some problems to fix. Okay, so I found one of the bugs. So when we have a long rectangle and it passes through the z-axis, we're seeing it strangely kind of flips around, which actually makes perfect sense. So when we look at our diagram that we made earlier, if we draw the lines going backwards, we can see that it is going to flip over. So we just need to say that if this total C gets so small that it's less than or equal to 0, we just need to cap it to some small value. Cool. So now we can make our corridor. Oh my goodness, we can make the first corridor of the back room. Doesn't work. Alright, I'm so hyped to be able to show this. This is where we're at right now. We can walk into the hallway. We can turn around. We can move left and right, and we can walk out of the hallway. There we are. Yeah. I guess the next thing to do is to stop that happening, where the green draws over the yellow. Epic. So here is a diagram of our screen, and one of the issues I was having, I'll put up some footage of it now, but whenever we turned around in the corridor, we would go through the walls of the corridor and see the corridor from the outside. And it was really confusing, so I was thinking like, how is the corridor coming in front of the camera? It's kind of funny actually, because that kind of thinking, how is it in front of the camera, is exactly why I couldn't solve the bug initially, is because there is no in front or behind of the camera, it's 2D. What I realized eventually, and it was on a walk, this diagram shows our Y, X and Z plane. The red is the computer screen. This angle is our FOV, and it's what we can see from the computer screen. The blue rectangle is what we're drawing to the screen, it's one of the corridor walls. And the yellow circle, that's the circle that the corridor will spin around on. So as the player turns their head this way, this corridor is going to move like this, and this bit of the corridor is going to move like this, and then it's going to draw over here. And the problem we're having is that when the corridor was facing forwards, you know, we would be here and we could see down the corridor. But as soon as the corridor came to about this angle that I've drawn here, we would be able to see the whole corridor. We'd be able to see outside the corridor, when clearly, you know, the player stood here. They should only be seeing it. They should only be seeing this bit of the corridor, not the bit that's behind them. Yeah, it took me a while to figure out why the code was doing that, but it makes sense because this coordinate of the corridor right here, if we go along and find its x value, it is all the way over here, right? So it is going to draw the corridor from here across to here. Like if we draw it, it would look like that's on the 2D screen. So the code was actually working fine. I just needed to do another step in the process, which is, if we have something that has one coordinate in negative z and one coordinate in positive z, we need to find the point at which that coordinate drops the x-axis, and then we need to set this point to be that point there. So this takes me back to GCSE maths. So we have to find the gradient of the line. So m is the gradient. Then we have to find c. We can find c by putting in x1 and z1. And then we need to find x when z equals 0. And we get x equals minus c over m. Okay, and that gives us this point right here. Then we set whichever point was negative to that point. It actually wasn't too hard to code. We've got it in here. So that was kind of the missing key here. I've also made it, as you can see, that if I click with my mouse, it gets rid of the cursor, and then I can spin around indefinitely. We're not bound by the width of the screen anymore. So it mostly works, but for example, the floor piece is being drawn before the wall piece here. If I'm looking at it here and I tilt my head, the entire blue wall is now drawn ahead of the orange wall. So my idea to fix this is to, every time we give our program a big rectangle, it's going to break it down into 1 by 1 meter chunks, and it's going to draw each of those, which I don't think should be too hard.
Stop the cap.
Okay, we made some progress. So we've got our corridor, and now it appears to be drawing everything in the correct order. The way I did it is, instead of sorting by the z value only, we sort by the distance to the midpoint of the square. We got lots of bugs, and I'm not sure what's going on anymore. Okay, I think I found what the source of the problem currently is. We have a shape. Only one of the 4 points is negative. We now need to not only calculate this point, which is what it was doing before, but we also need to calculate this point, and then we need to draw this shape. So we need to add another point. To keep things simple, this kind of difficult problem here, basically I spent a lot of time trying to figure it out, and I couldn't quite figure it out. And I also realized that if I just use my breakdown function to break this down into smaller and smaller pieces, the possibility of a player seeing this happening is going to basically go down to 0. And I also want to be using this breakdown function in the future to add lighting. So my plan is just to get the breakdown function working, and we see if we can notice the bug or not.
One eternity later.
So I've done a little bit of coding, defined a list of hallway rectangles and a list of corner rectangles, and then we're putting them into the breakdown, and then we're pushing them to the shapes, which is then going to get drawn. If I run it now, we have this, which is really nice, because what this does is it basically just fixes that problem without us having to fix it. Yeah, that's pretty much the 3D renderer done. Yes! Yeah! One thing I was very easy to implement after breaking things down into squares is
illumination.
So we have to get the RGBA values from the shape color, then depending on the global illumination and the distance to the camera, and I've also made a light, the distance to the light, we're going to multiply the RGB values between a minimum of 0 and a maximum of whatever their original color was. 1 over r squared is typically how light dissipates. What we have now is this, where in the distance over there we have a light which we can walk towards. This made me so happy, because this is really starting to look like a game. I'm going to try and make it so you can look up and down, not just left and right, which I figure should just be the same as what we're doing here for x. So let's try that. Wow. So verdict is we leave Y rotation for another time. Okay, so we're finished. So we needed to add collisions. So what I did is, when we create a rectangle, if it has a wall property and the distance to the camera is less than a certain amount, we're going to set this moved value. And when this moved value is set to true, we just undo the last movement. So basically, if we get really close to a wall, we just undo that last movement. And the list is always 3 long, so we have 1 corner piece, 1 corner piece, and 1 corner piece. If the person walks into the head, we generate a new head and get rid of the tail. If the person walks into the tail, we generate a new tail and get rid of the head. And then it just stays like that forever. And that worked really well. So let's take a look at what it looks like now. I can bump into the wall, and then it's just going to keep going forever, basically, with randomized lengths as well for each corridor. Then if I turn back on myself and go back the way I came, we can already see that it's like a slightly different maze. Yeah, so I'm really happy with this. And that's it. It was a real struggle, but we got there in the end. And yeah, you know. Why did I do this? Yeah, the next thing to do is add some sound effects. There's a 1 in 3 chance of there being another door appearing out of nowhere. And then when you click on that door, it'll take you into the back rooms. Yeah, eventually I'll add little keys hidden about, and then when you get 3 keys, maybe a door will appear and you can get back. But, I mean, I finished the scope of what I originally set out to do, which is to make a 3D renderer in JavaScript from scratch. It'll be on the website, eventually. I'm happy with this project. I want to get back to making my Tetris game, which you maybe will see some devlogs on this channel for soon, which is like Tetris, but it gets a lot of twists in there. So that'll be fun. And that's written in C, which is C with Raylib, much nicer than JavaScript and Canvas. Yippee! Thanks for watching, if you made it this far, by the way. If you did, why not like, why not subscribe? I'm going to be making more really bad content just like this for a long time, hopefully. So, epic. Bye.